Hey, hello, and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see the today's problem. So what the today's problem is asking us is there'll be an array given, right? And what we're going to find out is the element which occurs only once, right? When all the other elements are occurring three times, right? So in this case, three is the answer because it is occurring only once, right? And two is occurring thrice. Okay, so written three. So there can be various approaches to solve this problem, right? One approach would be to sort the array. So we'll sort this array, right? And what we'll do is we'll compare the current element with the next element, right? And if it is not same, right? If it is not same, then if it is same, definitely then that is not the answer. If it is not same, then that will be the answer. Okay. But this approach will give us O of n log n, right? Time complexity, right? That is for sorting the array. The expected time complexity is O of n, right? Another approach will be to have a map, right? The map will contain the key as an element, right? As elements, right? And the value will be the frequency. So 2 has appeared 3 times, 3 has appeared 1 times, right? So this will be the answer. We'll iterate to the map and we'll find out the element whose frequency is 1, right? So this will be the answer. But the space complexity will be O of n, right? We are taking map, right? Extra space. But the expected time complexity is space complexity is O of 1. Okay. So the approach which we are going to follow would be the bit manipulation approach. Okay. So what we are going to do is, as you know, right, integer contains 32 bits, right? So what we're going to do is, for example, what is the binary representation of 2? It is 0010, right? So in 32 bits, like there will be 000 and all, right? 00 and all. The binary representation of 3 is 011, right? 0011, right? And having 32 bits, the remaining will be 0, right? Similarly, for 2, we'll write this, right? 0010, like this, 0010. Okay. So what we're going to do is we are going to have first an outer loop, right? Int I equal to 0 to 32 or 31, for example, right? 31, right? For each bit. And what we're going to do is we are going to check. We are going to keep on checking from the last bit, right? To find out the set bits, Okay. So what it will be, and the internal for loop will be int j2 equal to 0 to n. That is to iterate the array, right? To iterate the array. Okay. And what we're going to do is we are going to keep on checking. We'll start from last bit, right? And we are going to check for all the elements, whether the last bit is set or not, whether each time we are going to do this. Okay. So, so what we're going to do, for example, right? Now we are going to have how we are going to check, right? Whether each bit is set or not, right? So we are going to have one, right? One, right? And we are going to left shift. For example, one, we are going to left shift by I, right? I is what? The counter for the bits, right? For the 32 bits. We are going to left shift by I. So in order to check this particular bit, right? In order to check this particular bit, right? So I will be 0, right? So left shifting, what does left shifting mean? One left shift by I. When I and I is 0, so it will be, what is binary representation of 1 is 001, right? 0001, right? And when we do left shift by 0, it will give us this operation only, right? If it is I is 1, right? And we are doing left shift by 1, that means what? We are going to push 1 by 1, right? Once. It will be this. If I equal to 2, what we are going to push 1 by 2 places. Okay. So it will be 0, 1, 0, 0. See, we have pushed 1 by 2 places. Similarly, I equal to 3, we will push 1 by 3 places to the left. Okay. So in this way, so what we are going to do is, now we have to check this particular bit, right? So we are going to push I by 0 times, right? 0 places, right? So what it will be? This result will be 1 only, right? 0, 0, 0, 0, 1, right? So what we are going to do is, we are going to take each element, right? The binary representation of each element, and we are going to do AND operation with this particular result, right? Right. So in this case, what will be AND operation, right? 0010 and 0001, right? So this operation is going to give us, right? If we have to check for this particular bit, right? So doing AND operation is going to give us, is going to tell us whether this particular last bit is set or not. So in this case, 0 and, you know, right? 0 and 1 is 0 only. So it will be 0. 1 and 0 will be 0, right? So this particular bit is not set, right? This particular bit is not set. So we'll not do anything. Okay. Now coming to this particular we've checked. This particular last bit is not set. We'll check this one, 001, right? And with our operation 0001, right? And operation we're going to do, right? So this will be set. This will be 0, right? This will give us, yes, this will give us a set bit. So in this case, what we're going to do is we are going to have a count variable, right? This counter will be for the set bits, right? This counter will be for the set bits. So in this particular case, right, we are going to increment the count. Count will be 1, right? Count will be 1 in this case. Then similarly, we'll check for the other elements, right? The last bit for the other elements, right? So it will be 0 only. It will be 0 only. Okay. It will be 0 only. So count will be 1. So whenever count, right? Whenever we find count, for example, Yeah, so in this case, what we're going to do is we are going to have an answer variable, answer equal to 0. And what we're going to do is we are simply going to do this operation, right? This operation. So answer or. So answer is what? 0 now. 0, 0, 0, 0. Now we want to have this particular set bit, right? As part of the answer, right? This particular set bit as part of the answer, right? So what it will be? 1 left shift by I. So 1 left shift by 0, right? 1 left shift by 0, it is going to give us what? 1, right? Or operation we are doing, right? Or operation means 0 or 1 is going to give us what? 0 or 1 is going to give us 1 only. You know, right? Yeah. So this will give us 1. So the answer will be containing 1 now. Answer is 1 now. Okay. Answer is 1. Okay. Answer is 1. So now what we'll do? Now coming to now answer is what? Is 1. Right? Now what we'll do? We'll come to this bit. I will be 1 now. We'll come to this particular bit, right? This particular bit. Right? And we are going to then we are going to left shift 1 again by what? I is 1 now, right? I is 1, right? So we're going to left shift 1 by 1 place, right? So this will give us what? 0, 0, 1, 0. 0, 0, 1, 0, right? So now what we'll do? We'll take each element, right? Now we'll take 2, right? 0, 0, 1, 0. We'll do AND operation 0, 0, 1, 0, right? This result has given this particular result. Okay. So we are, yes. So now 1 and 1 will be 1, right? So this means this particular bit is set, right? So we'll increment the count. Count will be 1. We'll increment the count. Again, we'll come to this element, right? This bit is set. We'll do the same operation 0, 0, 1, 1, 0, 0, 1, 0, right? And operation, right? This, right? So this will give us 1, right? So in this way, we are going to increment the count. Again, we'll come to this element. This is set bit. We're going to increment the count. This particular bit is set, so we are going to increment the count. Now, what we're going to do is, see, once you're done, right, for checking each bit, after ending this loop, after checking for all the elements, we're going to check count mod 3, we're going to check. If it is equal to 1, right, that means we have to consider this particular bit, right, the second bit for the answer, right, because the second bit, what? It is 4, right? It is 4. That means there are 4 elements, right? So 4 elements wherein the second bit is set, right? And the 4 elements are this, right? And these 4 elements include our answer as well, right? Include our answer as well. So what we're going to do is now, what we're going to do is, see, count mod 3 equal to 1, right? So 4 mod 3 is going to give us 1, right? So what we're going to do, earlier our answer was 1, right? So what we're going to do, as we know, what is the operation? Answer or equal to 1 left shift by I, right? So what it will be? Answer contains what? 0, 0, 0, 1. Now this particular result, it is going to give us 1. I is what? 1, right? I is 1. So 1 left it by 1 place. So it is going to give us what? 0, 0, 1, 0, right? And we are doing OR operation. So 1 or 0 is 1. 0 or 1 is 1. So this will be now the answer will contain 0, 0, 1, 1. 0, 0, 1, 1, it is a binary representation of 3, right? So it's a binary representation of 3. Okay. Now then we'll check the rest remaining bits, right? Remaining bits, right? And all the bits are going to give us 0. So one remaining bit, what? I is going to be 2 now, right? 2. I is going to be 2 now, right? So will left shift 1 by 2 bits, right? So what it will be? The binary representation of 1 is this, right? Will left shift by 2 places. So it will give us this. And we are going to do AND operation, right? AND operation, right? For with all the elements, and it is going to definitely give us 0, right? So this count won't be incremented, and right. So only when what we do this operation, right? This operation we do only when this is true. Count mod 3 equal to 1 is true, right? So yes, so we are going to do this, and we already have this answer equal to 3, right? So let's consider another example, right? 2, 2, 2, 1, 2, 2, 2, 1, right? 2, 2, 2, 1. So these are the elements, right? So in this case, what is the binary representation of 2? 0, 0, 1, 0. Binary representation of 1 is 0, 0, 0, 1, right? So when we check, right? 0, 0, 1, 0 again, 0, 0, 1, 0 again. So binary representation of 2, 1, 2, 2, right? And let's say the array is 2, 1, 2, 2, right? So when we say the last bit, right? The last bit only in this particular bit is set, right? This particular bit, the one bit in this element it is set, right? So what will be the count? Count is going to be 1 only. And right, 1 mod 3, what it is going to give us? 1. So in this case only, we are going to increment like this one, right? 1 left by 1, which is going to give us 1. Answer as 1, right? So this is approach. Let's quickly see the code, right? Let's quickly see the code. So as I said, we'll have outer for loop for the 32 bits, right? And we are going to have count variable. we are going to, this problem will be to iterate the array elements, right? And what we're going to see, we are, for each element, we are checking the set bit, right? At the ith location, right? So whenever the bit is set at ith location, the result will be non-zero, and we are going to increment the count. Once all elements are done, we are checking whether count mod equal to one or not, right? The remainder is one. If it is one, then we are including that bit in the answer, right? And then we are returning simply the answer, right? So the Java and C++ code is same, exactly same. There's no change, okay? So you can consider the same for C++. So let's submit. So yes, it is accepted. Thanks for watching. Please like the video and subscribe to my channel. Thank you.